Howdy, it's Mac from Walter Solutions, and today we're going to talk about measurement. Now, measurement is really important in a lot of different aspects of life, but in manufacturing, it's especially important because when we measure things, we can keep score of how successful we are, and we'll know if we're winning the game or not. So today I want to talk about 5 things that you should be measuring in your manufacturing process. So the first thing that we're looking to measure is planned versus actual output. Now, everybody has an idea in their mind of how far they can drive in a 2-hour span, roughly 120 miles. If I'm going 60 miles per hour down the freeway for 2 hours, then I'm going to go 120 miles. Well, let's say there's traffic. Let's say you stop at a rest stop because you want a burrito. Regardless of what it is, the actual travel time or distance is going to be different from what you planned on it being. So in manufacturing is no different. How many units do we think we can produce in this amount of time, and how many do we actually produce? If there's a gap between this, then we know that something is wrong. We are not making the full amount of units that we think that we can make. And as a result, we need to identify what's happening and why we're not meeting that goal. The next thing that we look to measure is downtime. Now, downtime is a reflection of the machine itself and the processes in place to keep machines up in working order. For example, a machine might have reliability issues. It might not start all the time. It might break often. These are all issues that we are not going to enjoy because it's going to prevent us from meeting our actual output. Now, there's planned downtime and there's unplanned downtime. As you can imagine, unplanned downtime is the bane of every scheduler's nightmare because now all of a sudden, the capability that you were relying on to be able to produce product is now gone. Okay, this machine is not working. We cannot make anything. So it's very important that our downtime is planned and we do the preventative maintenance measures we need to in order to prevent this downtime. But we will not know how big of a problem we have until we start to measure how much downtime we have. I would also recommend we keep a log of the reasons for this downtime. Why was it down? That's important to know if you want to fix the problem. Next, we're actually going to switch colors. We're going to go to red because our next item we should be measuring is our scrap. Now, scrap in my head is simple. We have raw materials that we convert into finished goods via the manufacturing process. Now, there's going to be a certain amount of scrap in that process that is allocated for. Now, example, you have a sheet of metal and you want to punch circles out of it. Well, no matter how tightly you punch those circles, there's still going to be an amount around them remaining. Now, this can be limited, but likely there's going to be a certain amount of scrap that is required in your process. Now, the scrap that we don't want is scrap that is caused by process issues. For example, a machine that hasn't been taken care of very well or not set up properly will yield scrap, and it will take away from your ability to make the amount of parts that you need relative to the amount of parts that you planned on making. So scrap's really important to measure. We also want to measure the reasons for that scrap. Examples could include bad setup, but that is a problem that is a root cause rather than a symptom. A lot of times I'll hear, we're making scrap because the machine is not punching the hole properly. Well, why is the machine not punching the hole properly? Is it because we didn't put the right die on it to start? Is it because the ram that the punch is moving on hasn't been lubricated in 3 years? I don't know. There's a reason for that scrap, and there's a symptom for that scrap. You're going to be tracking the symptoms, and it's up to your team to go down to the root cause and determine what it is actually causing that scrap. Now, the next thing we're going to look at that you should be measuring is your setup time. Now, setup time holds a place very near and dear to my heart. Setup time is the amount of time that it takes for you to take a machine and set it up for a given product. Most of the time in production, machines have to be able to accommodate different part numbers and different jobs so that the machine can be continued to run at all times throughout the day. So setup time is taking a machine and configuring it for a specific type of product. Now, when you're doing that, you need to know how long you're doing it for, because most places people are only working 8 hours a day, and every single time you run for a given day, you need to set up the machine. This is just an example. Some places run more often with less setups, but this is the example we're going with. Now, if you have an 8-hour day and it takes you an hour and a half to set the machine up, then you only have 6.5 hours left to produce. Now, that hour and a half can be dramatically cut back, and that is by either fixturing certain parts on your machine that require less manual adjustment, or simply just having a sheet, a setup sheet, that gives you the settings for a given job so there's no guesswork. We do not want setup time to bleed into the startup of the machine, because if you do not properly set up your machine, then when you go to run it, you're going to be setting up as you start it up. And not only will you be increasing the setup time, but you'll also be producing scrap in the process as well. And you're taking more time that employees are working to produce no goods. The goal is to take as little materials and man hours to convert into the most finished goods. So we want to be tracking our setup time. The last big one that we're going to be measuring is our first pass yield. So, first pass yield. What is that? First pass yield is the percentage of products that you make that go through the process one time and are completed. Now, your goal should be 100%, but in a perfect world, that's the case. Now, if you do have certain items that come off a line and might require extra finishing work or a second pass through the machine, then that is going to count against your first pass yield rate. And your first pass yield rate is important because you can identify what areas of your process need to be improved so that you can continue to be more efficient. So if you're going to measure, I recommend that you measure these 5 before anything else and go from there.